Hello, 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 hello. How's it going? Here we are. Let me fix this just a second. All right. Excellent. All right. Um Right, as you can see, I have Fusion 360 here. Let me make sure the stream is working properly. Yep, looks good. Cool. All right. Okay. I'm gonna be looking too far over there, but all right. So I have LD-F1's design here in Fusion 360. I wonder, can I bring up an image of that? Yeah, let me switch over and show you the image of the original. Right. So now what I'm going to do here, I could bring up a picture of the belt. Let me see if I can add an image source. Full wrapped in OBS here momentarily. Built. All right. Okay. Find the image. Not in there. All right, we want to go to endless scrolling here. You, and you, and find photos. I have a photo. Let's see. This one? See if this works. All right, unload image. I'm not showing because it's enormous. Okay. That is way too big. Need to shrink this image down to the size of. There we go. And also, I want to change to a different image because that's not going to show what I need to. Properties. Right place. This one? Yeah, looks like this one. This one right here. Okie dokie. Let me swap over to that for a moment. Fusion. All right. Tracks on Droid. I can turn those on momentarily here. There you go. Okay, so the sprockets on this this roller here actually turn the track, and those are turned by the belt, which goes from this pulley to the one on the back of the green gear. I will hide this track so you can see it. All right, there's the pulley on the back, and then the two gears are what actually turn the belt. Now, the problem I have is that the belt does not have enough tension, and it slips. It basically skips teeth right around this area. Largely because this pulley is very small in radius. It only has 10 teeth. And so the belt just kind of skips over it directly. All right. Now, why is this thing pink? I was trying to illustrate something in screenshots. So I'm going to make it one of these colors, probably this one. We can see what's going on again. All right, close that. And everything. Okay, I wanted to make the entire thing black, thanks. Find the part here. Chassis, body. This part. Front outer wall. I know you cannot see what I'm looking at here. I'm dragging this shape, this material over from the appearance browser to the actual browser, dropping it on the part. Remove these appearances. Okay. I think perhaps that's the wrong color. I'll use this one. All right. Okay, so we're back to black. Good, that's what I want. All right, now, as I said, the belt, which goes from the small pulley on this green, on the back of this green thing, to the large pulley here, basically goes from there to there and back. It's not tight enough, and I need to put a tensioner in here. I'm thinking I'm going to use this screw hole. It's actually the hole for a M5 threaded insert, but a M5 bolt goes into this hole, and that is what connects these two parts of the body and chassis. It keeps it in the slot. There's also another one there, and in theory a third one up here, which I don't actually use. But I figured I could build an idler. Flashing is annoying, isn't it? No, that's not it. Selection filters. Changing the filters on this, so maybe it will stop highlighting body faces. That's what I want. Maybe. Nope. Okay, well, some filter in here. Ooh, lets me turn that off, but I don't know. In any case, you can see in the background, barely. Turn off this, turn off this. You can see these dashed lines here, and you can probably make out that and that, maybe. But what this represents is the path of the outer edge of the pulley, or outer edge of the belt, rather. So the belt goes this way, boop, 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 around the loop, and back up this way, and comes back around. All right, so I need to put a roller in here, little roller, to push this line, bend it upwards, and make it tighter. And I'm not sure how much I need to make it tighter. I mean, how far it needs to be pushed to make it tighter, but it needs to be tighter, definitely. All right, now I mentioned this in some videos I posted on YouTube, but the roller for this device needs to be roughly from this plane to this plane, or really more accurately from here to here, because that is the width of the belt, more or less, or at least the potential width of the belt. The belt goes across these two pulleys. It's really probably more accurate to say this plane to that plane, or the plane that those lie along, I guess, because it's a little narrower than this this pulley is. But the problem is, of course, that I have to get it out here, and it can't rub against this part of this gear. So, and there's going to be a bolt sticking out this way, because a bolt's got to go in towards the body, where the part that I'm going to design to go here is, and threads in there, and basically spins, but there are bearings that need to go in there. And what I might do is just design a holder for a pair of bearings. I'd really rather have like flanges on it to let it keep it from, you know, coming off track, but we might have to settle for rollers or for, you know, just for the bearings. So as you can see, there's not a lot of room in between these parts for this. I have to be able to access the screw to attach it. So we've got a couple of things that we got to deal with here. Right. A drink. Can I put some music on without being ridiculous here? No, probably not. Can put on some music from here, but I'm not really sure I've got any that work for this. So, yeah, LBS back so I can see what's going on. Cool. All right. So, all right. So I know I need a few things. I need to make a sketch. Make a sketch, come on. All right, it's going to be on this plane. Stop moving my model, thanks. Fusion has this annoying habit of doing things without asking. When I use a sketch, it hides it, which is annoying. Wish it would stop. All right, so we want to project this circle, mostly so I can get the center point. All right, so there's a center point. Make that dashed so it doesn't affect anything. I'm going to back up. Look, okay, good. I'm going to I'm going to project these other lines on here. Project this one and this one. I'm going to need move things around. Good. Everything's working except my camera. Just fine. All right, project those two. In here now. All right, good. I'm going to turn off the chassis. Turn off the track drive. And I'm going to turn off these pulleys. All right. And this. Okay, so we're just left with this sketch. These two things. Here's the sketch that we had active before. Is over here. That off. All right, cool. All right, so let's get those out of the way. I don't have the belt path. Let's project that as well. Cool. Okay. Wait for Fusion to catch up. All right. So this is the original path of the belt, and we need to design standoff. I need to decide how far in I want it to go. I'm gonna make a line here that is perpendicular to the belt. I'm actually going to need those things that I just turned off. We'll find them again. Not that. That and structure. no, yes, no, no. The track chassis, not check. I did that already. Track drive, the wrong side. This one. All right, we can turn that off. All right. So I need to know how far in this needs to go. And I need to keep it. Okay, I want this to be like 80 degrees. No, wrong way. 110 degrees. Because I need the bolt head to miss this part. And maybe 100 degrees. All right, that seems all right. Okay. Let me check my parameters. Show parameter M5. Screw outer diameter is 5.5 millimeters. Inserts 8.2. M5 hole. Blah blah blah. All right. This one is 7.10. Now I can do an M4 axle for this roller. I can do an M3 axle for this roller. Those are the sizes of bearings that I have, or bearing inner diameters, to be precise. Okay, so let's make the M5 hole the wrong one. M5 screw outer diameter. Okay. Do I have an M4 screw head outer diameter? Axle hole. All right, there we go. Probably correct. 4.2. Might be too small, but we'll deal with it for the moment. All right, so I'm going to create a slot, center to center slot, across this distance. Actually, before that, I'm going to delete this line because it's going to create its own. And there's no point in keeping an extra line around. So, I want it to be M5 screw outer diameter plus 3, 5. Okay. Maybe plus 4. Now, you might notice an issue here, which is, I'll put my angle back first. 100 degrees, enter. All right, now the length I need to specify, go 11 millimeters, maybe even 10 millimeters. 10 millimeters. The deflection is going to be whatever the diameter of the bearing or idler is supposed to be. You're not locked onto that. Okay. Okay, so this is where the screw goes through. I will need either a hole or something to let the screw head go in as well, but no, think about it. This might not be the best way to do this feature because I might want this one narrower than this one. I'll cross that bridge when I come to it. All right. All right, so you might have noticed I put the sketch on the sidewall here, on the sidewall of the chassis. That's where it's going to rest. And the issue I said you might have noticed is that the sprocket would hit this thing if it went straight out. As soon as this tried to turn, it would hit this part. So this thing has to go up and then out a bit. So maybe the easiest way to do that is to put... You keep doing that. Stop it. All right. I'm going to remove the slot because I decided it's silly. Yep. All right. So what we actually want is a circle centered on this circle, radius M5 through outer diameter plus 5. And we want one centered on this one, which is M4 axle hole, hole plus 4, 3, 4. We'll go with 4 for the moment. The 10 millimeters is already there. That's fine. I don't actually want that, so put my line back. Make that a construction line. Tie these circles and such to that line. That's correct. Now I can make it 10 millimeters. And make this angle 100 degrees. Excuse me? What did you do? It's 96.8. Am I on the right line? Apparently I am. 100. What? Oh, I see the problem. You're not attached. 100. There we go. All right, so make this construction line, and then we want to connect this. That is an arc. It's not what I want. Connect this construction line to that one. Make both of them tangents. Do the same thing on the opposite side. And this will basically let me try that again. This will let me have the up there, okay, and it'll let me have a part that tapers in. So you want to be a tangent. Move this angle out of the way, and now I can just do an arc. At this point, are you connected? I don't think you are. Right. Point. Let's make it bigger. Come on. Okay. Let's make this bigger. All right, thank you. Now put this point, connect it to this arc. Right. Me. All right, well, that's a dumb way to do it anyway. You need the same radius as the other one, which is D2851. So D2851. Oh, it's a radius, I bet. Hello? Yes. Times 2. Nope. Am I dumb? What am I doing stupid here? That's what I'm doing stupid. This center point is not in fact locked like I thought it was. Okay, never mind. That was dumb. Now we do the same thing over here. See, I clicked on this point on the other side, and it still did not lock it to the center, which is annoying. Fusion, could you maybe lock these points together when I say lock these points together? That'd be good. What do you think? All right, so all right, that's good. Now I'm going to put another circle in here for M5. Actually, I'm not going to do that at all. Yeah. Okay, so this is basically our standoff. I just realized I don't need this second arc at all, because I intended to put this solid. It's okay. You'll see why momentarily. Perhaps. Or let's do it on this side. X. Yeah, let's do it on that side. The reasoning is that I don't want this entire thing sticking all the way up, because it might still hit this gear. Alright, so now we need to go to the side view here so I can figure out how tall to make it. Select the profile. Thanks. Alright, now we're going to go up to that object. Actually, that seems like a good place to go. No, I want to go lower than that. So I need my chassis. And I need to turn off this gear. I need to go to this point. Like so. That will clear the sprocket. Correct. Good. And now that's what I was talking about. Fusion has hidden my sketch and irritated me in the process. Right, there's my sketch. Right. Now, what is the distance that I have to work with this thing? Actually, I kind of messed that up. The object that I need to go to is, in fact, this surface. The reason is I want one of these little things sticking up for the bearing surface, not just like this. Okie diameter is that anyway? I can't read it. 10 millimeters. Okay. Now, we need to extrude. I was interrupting myself. How far do I have to work with? 5.563 millimeters. However, there's got to be a nut on both sides of this hole to hold the axle in. I suppose technically there doesn't, because the bolt can thread directly into this part, but it's really not the best idea. I can recess the hole, figure out what size that needs to be. Did I have one of those M4? M4 screw head outer diameter 7.7 millimeters. What is this diameter? 8.1. Okay. Well, let's select this and just build it. Extrude. Okay, I'm extruding from an object. Is this plane on top of this standoff. I'm extruding. I'm gonna go -4 millimeters. This particular sprocket could wobble a bit, and I don't want it to wobble so much. Maybe 4.5. Yeah, 4.5 is good, maybe. I don't want it to wobble so much that it can still hit this part. Okay. Yeah, I'm thinking. There is a way to ensure that this angle is as designed. Specifically, I could make a protrusion down into the slot down here. However, the problem with that is that it can't be. Let me find the chassis. Here's the chassis. Let's take the front inner wall. Inner wall. Front inner wall, and turn those off. Let's turn off the electronics box. Right, what do we got left here? Electronics box cover, go away. The ESP32 mount, the brain. All right. So it sticks through this slot here. So the problem is I don't have a precise measurement for where this screw is inside the slot. It can vary. The entire purpose of it being a slot is that it can be a different distance. So I could only put like maybe, some thickness in here to hold it in place at this angle, but not necessarily fill this whole slot. So that's a thought, but I'm not sure yet. Okay. Now, trying to decide how best to model this standoff. The bearings, if I'm doing an M4 like I have the hole specified here, the bearings that I have are 104 ZZ bearings. Those are 10 millimeters in diameter, 4 millimeters thick, and 4 millimeters inner diameter, so the hole is 4 millimeters. I will have to use 2 of them. That's fine, but the reason I'm wondering is because this diameter is 10 millimeters. Can't see it, but it's in the bottom corner. And this one is what I say, 8.2. So clearly, I don't want it to be 10. I don't want the equivalent of this little standoff or protrusion to be 10 millimeters. In fact, it should probably be, let's see, 10 minus 4 is 6, so 3 millimeters will make it 7 millimeters in diameter. So let's add that to our sketch. See? We're gonna make that 7 millimeters. It's about halfway from the open bore of the bearing to the outside. So it should line up pretty well. Maybe. I could make it smaller. 6. Try that. That's fine. Now here's a thought. This is the hole that I have for the axle, and I know that works. This is 4.2 millimeters. This one is also 4.2. Okay, good. So this one should thread roughly like the other one over there. All right, out of the sketch, boink. Take this shape. Let's extrude this from the surface and extrude to object this surface. Okay. Good, good, good. So I know that I will need a longer M5 screw for this process then. It will at least be 22.5 millimeters long. Actually probably a bit longer than that. What is this measurement? Get through here is 5 millimeters. I will have to give me a moment. I will have to remove the existing one. Not very easily. I think it's a 10 millimeter screw. So 5 millimeters, 22, 27 millimeters ish. I could put a recess for the screw head here. The thing. All right. Now I need my gear back for a moment. Gear, gear, gear. There you are. All right. So what I've done is I basically made a standoff like this one for this gear that attaches through the screw, which is fine. Now, I need it to go up to roughly this point, this line. Well, no, I need to go up to this line-ish. Those collinear, I wonder. Unclear. They might be, but this might be sticking out a little bit more. Now, the problem is I can't make a little flange thing like this. Because that will make it more likely to rub against this gear if it sticks out that far. Am I dumb? What did I just do? I am dumb. Oh, no, I'm not dumb. Okay, I'm good. I was just having a minor lack of comprehension of what I was doing. Let me look at one of my screws. I have some M4 bolts. Some M4 bolts right here. Ready? These are M4 by 20 millimeters, which should be plenty. I might grab a model from McMaster Car and in there. Calipers. Alright, so the outside diameter of this screw head is about 7 millimeters. Yep. Okay. So that's the problem. This is the 6 millimeter circle from the center of this part, or the center of this hole. 7 millimeters will be slightly wider, and you notice how close this perimeter comes. Where's my sketch? Here it is. Sketch. Hello. Oh, okay. It doesn't have the doesn't have that diameter. Okay, so this basic arc right here. Can I stick this on the sketch? I will try. Yes, I can. It's trivial to do so if Fusion will respond. find. I gotta project the point. Okay, see from here to there. All right. So you can see if this is screw head sticks down too far. On the part, screw head sticks down from the surface too far. It could very well hit this thing, especially if this thing is wobbly, which I built the droid, I know it is. So it might be a good idea to make a recess for that. How tall is that? Come back. About 3 or 4 millimeters. 4. So the screw head on this is 4 millimeters tall. I thread into the plastic. I don't think it'll come back out because it is just bearings, but okay, so what I'm thinking, let me insert a component here. Gotta go find it. Screws and bolts. Metric. Want to insert an M4 socket head screw. Length of how tall is this? I don't know yet. Okay, well, I can't find out. I can't find the part until I find the bolt. So it must be from this distance to this distance. More or less. Maybe a little taller, but probably not. And that distance is 12.6 millimeters. Okay, so I don't think the screw would hit the green gear. Screw head were up in this area. I don't think it'll hit the green gear. Could be wrong about that. No, it's fine. It is way, way far away from that circle of 7 millimeters. Let me orient properly here. Okay, so that's 6. It's slightly wider than that. So this pulley's fine. I can have the actual idler go from that surface, also that surface, up to at least there, 12.6. If not, in fact, go to that surface, which is 13.4. Okay, 12.6. And the head would stick up past that. Plus, there would be threading into here. 5.5, so 17, 18. An 18 millimeter ish M4 bolt. I mean, the 20 millimeter would work just fine. Okay. That seems plausible. You know what? I can turn this. So I'm not using the model right now. I can turn that off. Cool. Get a drink. I will say that this part is likely to be a pain to print. I'll need supports on this arm. But that's fine. Alrighty. Where am I creating in here. That's fine. All right, you're going to be idler and off. Okay. Rename the part. It's time to save, perhaps. Okay. But yeah, doesn't matter if the screw sticks out below this hole because I think that is far enough away. It will not strike drive wheel here. It's just the screw head that I'm concerned about. Because the distance between here and here is not that. Oh, I'm not in the sketch, that's why I can't do that. Alright, distance between here and here. Minimum distance is 1.488 millimeters. Still kind of close, but fine, more than likely. Okay. Okay, so what was it? I said 20 millimeters. Okay, let me go get a screw to stick in. Screws and bolts, metric, M4. M4. 20 millimeters. Socket head. Don't really care which material it is. Fully threaded. Alright. This one works. Let me put it into step. And download. And now we wait for fusion. Ah, there's a screw. Alright. Rotate the screw this way. Alright, and oops, no, it's not. Yes, let's. It doesn't matter. Need to rotate it, or doesn't matter where I put it. Fine. I'm going to put a joint right on the underside of the screw head, and then I'm going to. Can't do that yet. Actually, put the part on that is supposed to sit in. Okay. In that case, let me grab two bearings as well. Insert component. Bearing. Whatever, revert position, it doesn't matter. Excuse me. All right, insert component. Bearing. These are going to be 104s easy. Bearings. Wait, 104. Hello? 104 bearings. All right, 10, 4, 4. Yeah, perfect. Step, download. Those. Did you download? You did not download. Yeah. 04. Bearing. Step file. Download. Thank you. Yeah, fine. I don't really care where you put it because it's going to have to move. So look down at the bottom. Why is it there but not visible? That's bizarre. There it is. Okay. Came in invisible for some reason. All right, so we got a bearing, we got a screw. That's cool. That's all I need. Don't really need these rollers on here. You, and the rear. and the small one. Okay, so this is all I care about right now. How long have we been going? An hour almost. No drop frames. I'm impressed. Didn't jinx it. Alright. Should I grab an M5 screw as well? Yeah, let's do that. Screws, bolts, metric. I do tend to use the word screw and bolt somewhat interchangeably out of habit. What did I say? 22? Go with a 25mm long bolt with a socket cap, fully threaded, like you. Download. Download. Come on. There it is. Okay, so there's the M5 screw. Cool. And it is, of course, invisible as well for no apparent reason. Alright. Actually, I want it to be invisible for the moment. Now I need to model this roller or whatever. Okay. I'm going to put a construction plane. Yeah, whatever. Capture position is fine. Okay. I'm going to align it with this this particular plane. It's going to be 0, and I need the construction plane to be visible, which would be the most useful state for it. There we go. Are there any others visible? No. Okay. So that is approximately the top of this roller. Let's go with the bearing version first, because I'm going to have bearings on here anyway. It's occurring to me that I might need this thing here be actually up here. Further up. So, we fix that. Or I make this thing there. I'm going to pull this up to this height. Or slightly below it. 3mm. Wait, what's the thickness of this bit? 1? Yeah, so I'm going to pull that up by 2mm. 2. Alright, then we're going to add a further 1mm on top of that. Profile plane here. To object. Change the object. Hello. Thank you. Oh, and select the profile. Here it is. All right, there we go. Yep, that's good. Okay. All right, so I need to make the pulley thing idler. How thick are these? Or how thick is this distance that I need to go? .6mm. Okay. Thickening this part, by the way, will make the screw threading in better. 10.6mm. These are 4mm in diameter, or thickness rather. Where'd they go? Oh, I went back in history. That's right. To put the... I really should move all this stuff further back, but whatever for the moment. I'm just noodling around for the moment. Okay, let me grab the... I don't think I can get away with 3, can I? They're 4 millimeters thick. That would be 12. What you got as the actual thickness here? Yep, 4 millimeters. Okay, turn off the screw. All this stuff because it's a bit excessive. Okay. Joint. I'm going to put a joint that and a joint on this. Okay. There's one bearing. Okay, let's add a duplicate of this bearing. So copy and paste. Paste. Fine. Okay. So I would need a spacer, or I would need 3 of them, or I need separate idler. This would be the simple way to do it, though. Pondering. Third one would put it... I'm going to paste again. And, alright, let's move that one out. Sure, I don't care where you put it. I'm going to be moving it. You down to you. 3 bearings, no waiting. Okay, there's not a lot of distance here between these 2 parts, but they don't overlap. So that's fine. I can hide this construction plane because I don't know if I need it necessarily. Hide the sketch for the moment. Alright, let's put the bolt through here in a moment. First, I'm going to grab a color, make this light blue. Cool. All right. And also, let's make these bearings silver. There we go. Just so they are a little more distinctive. I could, in theory, insides red. My little part. Okay, good. It did cover all 3 of them. Cool. The bearings don't actually look like this, but that's okay. I don't care. All right, now the screw. This screw. Now we can put the joint in. Actually, this screw is now too short. That was a, or is it? Yeah, it is. Need to go from here down to here. No, it's not really too short. Actually, just about right. Take out a little bit. But that's okay. So let me make this thing silver or black or something. Just to give it some nice looking appearance. Metal coatings, black oxide coating. It's a little hard to see. Also, that's a download thing. Iron, aluminum, brass. I'm gonna make it brass just because I can. It's not actually going to be brass. Maybe matte old brass. Wink. Maybe not. Maybe polished brass. Polished brass, yeah. As if I have gold, hardware in my droid, or brass, I guess. Alright, so let's get the joint, connect to that point. Go over here, connect to that point, and flip it around. So, something like this. And then I get my M5 screw. M5 screw, there you are. Length did I get? 25? Alright. J. Or joint. Put the joint here. That is not long enough. Okay, let me find this screw. I'll add a different one. Let's delete this. Delete. All right, let's delete this. Delete. Yes. Don't care what reference is it because it's going away. All right, give me my chassis back. Body, chassis, where are you? There you are. Okay. I need it to go in. Should have those inserts in here somewhere. Maybe. It's weight bearing. Actually, I know what I need. I need the electronics box and not the front outer wall. Front outer wall, I need the electronics box instead. Electronics box has the hole. Alright, so I need to go from the base of this hole to here. That is 35 millimeters. I don't really need the full 35. I could probably get away with 30. Seems about right. So let's go get a 30 millimeter M5 screw to get in here. Okay, bolts, metric, M5. Check. One at 30 millimeters long. We want it to have a socket cap head and be fully threaded. You. Download. Cool. All right. Wait for Fusion to catch up. All right, here we go. Let's move it out here so I can see it. Let's make it also brass, just because. Actually, no, I don't want to make it brass. I want to make it fancy anodized blue aluminum. There we go, just so we can tell which one's which. Okay, so that bolt goes in that hole. Just like that. And now I can turn the other part of the chassis, the front outer wall on. Say, okay. All right. That would probably work. Except I see a flaw. See a flaw in my plan. A pretty big flaw. This head sticking up here, would... No, actually, it's not a flaw at all. It's fine. I'm dumb. Because the belt is going to go from this pulley up. I'm going to turn off these, selection filters. Don't select anything. All right. Belt's going to go from out here somewhere up past this bearing and then around the other side and onto this pulley and then around and loop back around the other way. So it isn't going to hit this screw head at all. Now I need to add in the other components that I disabled, like the track drive infrastructure. Track infrastructure goes there. So that is the main other part that I would be concerned about. It just couldn't hit this roller carrier thing. I think we're fine. I would consider pushing this in a little bit, maybe. It doesn't actually matter if this this thing sits at the right angle, because what I could do with enough clearance is rotate it slightly to change how much tension is on there. It would be better if I could make it sit a little higher, but that's okay. All right. I think that is a design I can test out. It doesn't require a lot of printing. I have the bearings already. I will need... Which screw is this? This is this one. How big are you? I'll have to go look and see what length I made it, but it's... Oh, I turned off the selection. Good job. Turn back on. Hey, you to you. Yeah, 20 millimeters. Okay, so I've got the screw for the M4. I don't have the screw for the M5. This one. Because it is long. I don't have M5 bolts that are that long. That looks like I have enough thread inside this insert to hold it. Oh, I think this would work. Maybe. My main concern is only, is this too much tension? Is this not enough tension? I don't actually know. But like I said, I could rotate it slightly to change that. Probably not a lot because of this distance. I'm considering pushing this up. Let's push that up by 1 millimeter. 1. Why can't I offset that? 1 millimeter. Seriously, why can you not? Okay, let's put it this way, -1. All right, 1 millimeter shorter, 2 millimeters longer. Cool. All right. Not the most efficient way to design something, but okay, it's fine. It'll work. I can't go too far this way because the screw and the sprocket will probably hit, but at least it'll keep the sprocket from wiggling enough to hit this arm. Okay. So I think that is the part that I'm going to try to go with. I already know the screw here is correct. I really need to get my M5 screws out and measure tolerance with my tolerance checker. If you wish to see tolerance checker, you can check my printables account maybe. Let me see, I'll just put a link in chat. You go find it first. Need to go to it anyway. Printables. Alright, find my models. I'll put a link to my tolerance gauge. These are for, well, actually, it doesn't matter. My tolerance gauge only goes from 9 to 12 millimeters in diameter. It is based on a tolerance gauge on Thingiverse. I'll link to that instead. It's metric screw clearance calibration plate by Super Jamie. On Thingiverse. If you're watching the VOD, you won't be able to see the link. So let me drop that. Yes, great. Alright, so there's the link to the tolerance gauge that I've got printed. That lets me calibrate the hole size to my printer. You would basically just stick the screw in the whatever hole gives you however much tolerance you feel you need, and then change the diameter of the screw hole to match that. But I don't have one of the M5 screws handy, so I can't actually check that. I'll have to take one out of the drawer or find one. Yeah. But that means before I print this, I just want to verify that this diameter is what I want. I already know the other one is kind of what I want because it's the same diameter that's in this post, and I know that works with the M4 screws. Right. I think that will do it for the time being. Let me look and see what's going on over here. Nothing major. Yep. Okay, I think that's cool for now. Let me save this. I mentioned saving it earlier and I didn't actually do so. Alright, and we'll look at the actual path here. I need to make another sketch. Why not? I have a whole bunch of extraneous sketches that I have getting in the way. I really need to clean this project up a lot, but for now it will do. If you're wondering why my voice sounds weird, it's 4 a.m. Right. This sketch, yeah, is where? Where is it? Oh, okay. Oh, we'll use this one. I guess we'll project from this. Project from this. That's good enough. Alright, hide that. Turn this one back on, which I just turned off. Right now, and we're going to project onto here also these rollers. Okay. X. Oh. X. Thank you. That's not the right angle. Alright. Turn this stuff off for a moment. And we put a line there to here. Line from here to here. I make this one tangent as well. this one turns it as what? All right. I'm going to project this one. Okay, so that's roughly how much deflection this has. Could I go further? Maybe. I don't actually know how much it needs. Possibly more than that. Track drive. All right. That's 10 millimeters distance between this point and the center of that one. But I suspect if I push it any further, this bolt here is going to hit either the gear or the sprocket. That bolt. It's either going to hit this part. Well, no, actually, it won't. But it might hit this part. Drag it up here so we can see. I don't know. I'll see if this is sufficient to fix it. Fix the slipping on the pulley. If not, I will experiment with making this arm longer to tighten the belt further. That sounds like a good plan. All right. I think that will do it for now. Thank you for joining me or for watching the VOD. If you wish to see my printables, it is not there. My printables page is go to printables .com/@dyne DYNE, and that's where my models end up. I do have a Thingiverse page, but I don't update it anymore. So there you go. All right, thanks for joining me.